Hi, Michael Salmon here. Just a real world example of calculating kV value, why we would use it and when. Okay, so here is a 3-port rotary valve which is being used to blend the water flow temperature down to this heat consumer here, which could be say an underfloor heating or radiator circuit. From this heat source here, it could be a boiler or a heat pump. Okay, so what's important is this valve here needs to have good authority, which is good control over this circuit here, because it's here through ports A and B where this valve is controlling the flow to give the blended water temperature down port AB. Okay, so let's say we have a design flow rate through here of 1.2 cubic meters per hour, and we have a pressure loss where the mass flow is varying, where the valve is controlling it, of 0.294 bar, which was around 3 meters head. Okay, and what we need to do, we need to find out what kV value valve we need to select. So we'll go for the target authority of 0.5. We can have authority can be between 0 and 1. We couldn't have 0 because that would mean there was no pressure loss through here, and 1 would mean there'd be no pressure loss through there. So the answer is always between 0 and 1. Close to 0.5 is normally a good starting point. If we go much more above 0.5, it can use a lot of pump energy, and if we go much below 0.5, then this valve would not have much authority and good flow control. Okay, so we can use this formula here. We get the flow rate through the heat consumer circuit, and we divide it by the square root of the pressure drop through this circuit where the valve is controlling the flow, and this would give a kV value of 2.2, which is how many cubic meters per hour it would take to lose 1 bar in pressure. So I was looking at valves, and I found a valve here, a half-inch valve with a 1.6 kV value. Okay, so we want to find out what authority this valve is going to give. First of all, we need to calculate the pressure drop through this valve. What we do, we take the flow rate, the 1.2 cubic meters per hour, and we divide it here by the kV value, 1.6, square it, which will equal 0.56 bar. And then for the authority, we get the 0.56 bar, so the pressure drop across the valve fully open. And then we add that onto the pressure drop through the circuit in which the valve is controlling the flow. We divide it into it, and we'll have an authority here of 0.6. I did try this example. The first valve I tried had a kV value of 2.4, which was a 3/4 inch valve, and the authority was only 0.4. So I went for a smaller valve, the half-inch valve, which gave me an authority of 0.6, and that's satisfied my requirements of a valve authority of equal to or greater equal to or above 0.5 and as close as possible to it. Thank you.